levels. And so in the last class, we went over read uncommitted and read committed. And the idea of the isolation levels is that, what kind of output can you see? Do you see only serializable outputs or non-serializable outputs? So we did read uncommitted and read committed. So I'm going to do repeatable read, which is the MySQL standard. So by default, all these, any transaction or any query you've been running has been running under the isolation level repeatable read. So we have, okay, so this is the MySQL, like I mentioned, it's the default level. And so with repeatable read, we have that the output is always serializable. And it's atomic. And this is the thing I mentioned. So look, it looks wonderful, except there's always some kind of, trouble in there. So the issue with repeatable reads is that you have something called phantom reads, and I will explain it. So repeatable reads is a little more complicated. For one, this phantom reads concept is a bit weird. And two, because a lot of this you can't see in MySQL. Sometimes MySQL varies from the SQL standard. So the SQL standard is, so that's a bit confusing because of that. So, so I'll go over it slowly. So I'm going to again go back to this bank example. I'm going to explain it using the two examples I did in the last class, the bank example and the salary example. So in the bank one, we had these two accounts with $100 and $50. And the idea was that you transfer $10 from one account to another. So the only two legal outputs were, are 90 and 60 after the transfer is complete, or 150 before the transfer is complete. So those are the only two where the output looks serializable. So let's look at phantom reads and see how, let's look at repeatable read and see what happens. So we have user 2 who's doing transaction 2, which is set transaction, isolation level is repeatable read. And then we start the transaction. So this is T2, and then T1 is just the regular one where we commit. So you have U1 and you have T1 where the transaction's happening, and then that's Q1 and Q2, and then they commit. Okay, so I'm again going to show the, this part where we show the execution order by time and the output. So I'm just going to copy the left instead of having to retype the whole thing again. So we have execution order, and then we have time. So we have the same sequences. I'm just going to remove the outputs out here. And okay, but these are so the serializable is always the same on both sides. So the first two options where the execution is serializable, the output's also serializable. So that's not a problem. So we're going to look at the last four, which are all non-serializable. So in this case, the output for the output for repeatable read is always serializable. So you're always going to get the T2 followed by T1. So it's always going to be 150. So even though the execution even though in reality, the queries in real time, they were concurrent queries. So in real time, they were concurrent and these queries interleaved. But the execution always looks as though T2 happened before T1. So so you're doing the readings before the writing. So that's repeatable read. So it looks very much like serializable, which is why it's the default mode. So in order for me to show you phantom reads, I have to actually give you a different example, and I'm going to go to the salary example that we did the last class. Yes, this one. I'm going to add on to it, the one on the left. So I just want to say concurrent execution, but serializable output, which is a good thing, you know. So for all of these cases, but the output was always serializable, so it's good. Okay, so I'm going to first write down a little bit about the repeatable read to try to show the phantom read part. So the first thing is that in repeatable read, you'd never read dirty data. You're always reading committed data. And so let me just write this down, and then I'll try to kind of explain this. So if an item is retrieved the first time in a transaction, then the identical item is retrieved again if the query is executed again. Let's put this one. So I know this looks confusing. I'm saying if an item is retrieved the first time in a transaction, then the identical item is retrieved again if the query is executed again. So basically what I'm saying is the very first time you execute a read query in repeatable read, it uploads the data into a cache. And the next time it has to look for that item again, it only looks in the cache. It doesn't go down to the database. So going back to the salary example that you see on the left, oh, sorry.
I have a quick question. So up above where you said it always was T2, T1, wouldn't, if it cached with those first, where you're first grabbing the is that a salary or is that, where you're first looking at it, wouldn't it be T1 and then T2 then for some of those?
So what happens is that, let me just come back to, let me point out here. So you're looking at this one, right? This
Yeah, yep.
Okay, so Q1 is the query, which is updating. Let me just go down to the bank.
Oh, okay. So the big Q, sorry, well, then it down below where you have the little Q first, wouldn't that be then?
Yeah, so here the big Q is getting, so what happens is that, remember, these are all dirty reads. It hasn't been committed yet. The commit is only happening out here. So the commit only happens at this point.
Oh, okay. You said, okay, never mind. Yep. I see it now.
Yeah, the only one that reads dirty data is that uncommitted read. Even committed read will never pick up. At this point, it's just dirty. So it does do this. Um, it does do this Q1 x is equal x minus 10, but it's not yet committed. So
Okay. Yeah. Yeah.
that's the reason.
All right. Thank
Yeah,
you.
so it is kind of weird, it's so always the dirty part is only for the uncommitted read. Even committed read only picks up from a committed database. So, and everything above that, so all of these, they are only picking up from a committed database. So this read uncommitted is the only one from where you can get dirty reads. Nothing else is going to do dirty reads. So yeah, so that's the reason that when you come down here, even if the reading is happening after Q1, it just gets the committed stuff into the database. So let me just go down to the next example. That's a salary one. Yeah. So I want to look at just go over this one. So so even in this case, now if you look for the salary, when we did read committed to, we had a few cases where the output was non-serializable. But when it comes to repeatable read, the only outputs you can get are going to be um, the um, the serializable outputs. So let me just write this down. So the salary example. Um, so they're either 30-30 or the 230, 230. So all the outputs, doesn't matter how you interleave, the outputs are always going to look like it was serializable. It's either going to look like T2 happened first, followed by T1, which is the read happened before the update, or it'll look like the update happened and then the read in exactly serializable order. So the outputs are always serializable, even though the execution could be non-serializable. So what is the meaning of phantom reads? So let me put that out. So again, let me write it out first, and then I'm going to update the salary transaction example a little more. So let me just first write down something, and when I write it down, it may not look clear at all. And hopefully the example will make it clearer. So, but the same query issued the same read query issued multiple times can give different outputs due to, and this is the thing, they have something called phantom tuples. So you have something called phantom tuples, and let me write down what they are. So phantom tuples, they are insertions of new tuples into the table while this repeatable read, so I should say, while this repeatable read transaction is running or executing. Okay, and I also will want to highlight that this is the SQL, this is the SQL standard by the phantom tuples. Okay, so I'm going to go back, revisit the salary example, and I will try to show how phantom tuples appear. So I'm going to just go back to just this one screen. It's kind of, so let me just close the one on the left, because it is a bit difficult to keep switching from one screen to another. Okay, so let me give you an example for, so I'm going to do the salary, but I have to update it, the salary example. Okay, so we have transaction T1, which is 2 queries Q1, which is update employee, set salary is equal to salary plus 100. And now I'm going to have a second query Q2, which is insert. So I'm going to insert into the table, insert salary, insert into the table. But right now I'm just going to write it in short form. Insert salary is equal to 31. Okay. So these are the two queries. So let's say initially this is what the database looks like. We have, so before T1 is executed, so before T1, this is what it looks like. We have salary, and we have two values in there, 10 and let's say 20. Okay, so that's what we have initially. We have, this is before T1. So now I'm going to update. So that is after Q1. So after Q1, I will have salary, and I've updated it. So now I have 110 and 120. Okay, and now the last one is Q2. So after Q2, I again have salary, and now I have 110, 120, and I've inserted 31. So I put 31 in red. So now I've inserted this new okay, so this is what the table, if T1 goes through properly, this is what it should look like. So now let's have another query T2. So I'm going to have query T2. And this time I'm going to call it S1 and S2. I mean, writing saying small q1 and small q2 was such a pain. I didn't realize it till I started teaching. So I have a query S1, which is select sum of salary from emp. And I have S2, which is going to be the same thing. Select sum of salary from emp. Okay, so now I have this. So let's look at the execution orders that are all possible. So we have 4 queries, and I'm going to, just like the previous stuff, I'm just going to show, so execution order by time. And I have the output of T2 by time. Oh, not by time so much as what's coming off. So we have this. Okay, so I'll just write down all the possibilities. So we have Q1, so this Q2, S1, S2, we have, let me just move it a little bit to the left. Okay, and we have S1, S2, Q1, Q2. So these two are the serializable one. So this is like doing T1 first, followed by T2, and this is T2 followed by T1. And for these are serializable execution, and the outputs are going to be serial outputs. So we have for T1 followed by T2, you have output 261, 261. I should keep a gap between it. So we have 261 and 261. So this is again T1, T2, it's serial. And the other one is 30, 30. So it's T2, T1, that's serial. So, I mean, these are the sums that we have here. The sum is 30. Here the sum is 230. And here, sorry, the sum is 261. So everything is this part fine. I mean, I hope you have no questions up to this point. So now let's look at the non-serializable execution. So we have Q1, S1, S2, Q2, S1, Q1, S2, Q2, Q1, S1, Q2, S2, and S1, Q1, Q2, S2. So all of these are all non-serializable, all of these. So the question is that, what kind of outputs can you get when you, when you have these non-serializable execution, what kind of outputs can you get on the T2 side? So instead of starting with repeatable read, I'm going to show this example. So I have not done this example with read uncommitted or any of this. So I'm going to show what the various isolation levels will give you the output. So if you look at it, these four are non-serializable. So let's take a look and see what kind of outputs. So the thing is, we look at outputs given by all isolation levels. So one is that in all isolations level, you will always get the serializable. So this you're going to get in every single isolation level, you will always get the serializable output. So all isolation levels. And the only two serialization outputs that we have are 261 followed by 261 for x and the sum, which is when you have T1 followed by T2, or you can have 30 followed by 30, which is T2 followed by T1. Okay, so I'm going to do this for every single isolation level. So we'll start, and I'll get to the repeatable read. So I'm going to start with read uncommitted. So T2 runs with read uncommitted. So let me just copy this down. So we have, so these are the four cases. Copy. So these are the four non-serial executions. Okay, so let's look at all the possible outputs. Output of T2. And let me just copy down these tables, just so that we have it down with us, because it's difficult to copy. I'll bring it down here so we can see it out here. Okay. So this is what it should look like. So when you have read uncommitted, where you can do dirty reads. These are the possibilities. When you have Q1, S1, S2, Q2, what will be the output? So why don't you also do it along with me? So I'm going to sit down and do it. So Q1, okay, so it's going to be 230, 230. So it's non-serial. S1, Q1. So this will be 30 to 30. So this is also non-serial. Okay, does this look right? Did everyone kind of get this for read uncommitted? Does anyone have any questions on this? Let's put it that way. Okay, so this was read uncommitted, where you're doing dirty reads. So these are all the outputs you could get with read uncommitted. Okay. Okay, if you have any question, just jump in. Okay, so now next, let's look at the T2 runs with read committed. Okay, so again, we look at the non-serial executions. Okay, so I want you to do it. I'm also going to write it out here, but I would like for you to come out also with the outputs, all the possible outputs that you could get for read committed. Okay, so if you look for read committed, the last two were non-serial, but the first two outputs were serial, because in a read committed, you're always reading from a committed database. So since the commit is only happening after Q2, since S2 runs before that, it's picking up from the initial uncommitted database. So you're going to get 30 and 30. So did everyone understand the read committed and the uncommitted? Okay, so now I'm going to show you repeatable read, and I'm first going to show you what MySQL will do, and then I'm going to show you what because MySQL doesn't always show the phantom tuples. So I want to show you MySQL, and I'm going to show you the SQL standard. So first I'm going to do repeatable read. So T2 read. And so let me just write down. So this is very important that MySQL does not, so it does not show phantom tuples when um, when T2 is when T2 only has read queries. So what I'm trying to say is, see, both the T2 queries, S1 and S2, they are not updating the database in any way. So they're not inserting, adding, or deleting in any way. So because of that, in MySQL, it never shows phantom tuples. So let me show you the output for MySQL in repeatable read. So let me, so let me just copy this down anyway. So in all cases, it's going to show you 30, 30, 30. So all the cases are going to show you serializable output, which is T2 happening before T1. So what's happened is that in repeatable read, again, you have to pick up a committed database. So the commit is only happening after Q2. So in the first two cases, it's easy to see the 30 and 30. Now, in this case, the last two cases, Q2 is happening before S2. But the thing in repeatable reads is that it reads from a cache. The very first time you read from you read a table, you read it up from the disk and you bring it up, committed one. And after that, till you finish your query, you're going to continue reading from the cache. So that's what's happening for in MySQL. It's so repeatable read. So that's very important to remember, is that if an item is retrieved the first time in a transaction, then the identical item is retrieved again if the query is executed again. So what's happening is that you can think of it as putting it into some kind of cache, and it's reading it from that cache. So that is the reason that it gives you all serializable. So now, and this is the tricky part, is this is the MySQL, the way MySQL works. But now I would like to show you how it is there in the SQL standard. So again, I'm going to show T2 runs. And this time I'm going to show for the SQL standard. So this is for SQL standard. Okay. Okay, so let me just cut and paste the tables down so that you can see the tables. So I want to just bring it down. Okay, so this is what the tables look like. Okay, so the first two cases where the query Q2, which is inserting, is happening afterwards. So those are fine. So these two are fine. So for these two, we are going to have output it's not going to change. It's going to be 30, 30, 30, 30. So it's the next one. So in the next two cases, this query Q2 is happening, and after that, there's a commit is happening out here. So after this point, it's committed. Okay, so what's happening is that if you look at these two, S1, so when S1 is happening in these last two cases, they are looking at, this before T1. So they're looking at this. So this is the one that's being updated into cache. So these reads, so let me write down. So um, uh, this table loaded into cache. Okay, so out here, you're going to see 30 and 30 for the, the first fine is fine. So now this is the problem, is that the second time around when it is doing these two transactions, so in cache, you have salary and you have 10 and you have 20. Uh, it's a bit messy out here. Let me just move this to that side. I don't have, so let me just move it here. Okay. There's no space out here. Okay, so okay, so this is what's there in cache. But the thing is, now you have this new row that has got inserted. This 31 has got inserted. So what happens is that is a SQL standard, is that anything that got inserted after the query runs does show up out here. So this 31 also shows up out here. So when you run S2, when you're doing the sum part for S2, this is the table that it's seeing. It's seeing 10, 20, and 31. So because of that, the sum out here is going to be 61 and 61. So I know this is like really, so these are called phantom tuples included. So take a moment to look at this and see if you understand what's happening. It's so weird. I mean, it's seems almost, it seems kind of illogical, but it's because of the setup of how it's locked and stuff below. So do you understand this? Do you kind of get what I've done out here? That's why I said this was really a difficult topic to explain, because partly because MySQL doesn't follow the SQL standard. But if you start reading about anything in the books or any place, you read about phantom tuples. And when you work in industry, it's not, you might be working with a database where you have phantom tuples happening. So I want you to understand, because when you read it, it's so confusing. It doesn't really make sense. So,
So MySQL won't have the phantom tuples, is what you're saying?
well, that's the whole thing,
Or you're not guaranteed, basically.
No, you will see it, but not,
Oh, oh.
not. And that's why I said it is so, so confusing, because in MySQL, it doesn't show it, because in this case, the transaction T2 is a read-only transaction. It is not doing any updates. So I will show you an example where you can see phantom tuples in MySQL and you can try it out. I'll give you an example, maybe not today because we only have 10 minutes left in the last day of last class is on Monday. So I'll give it to you on Monday because I want you to kind of, over the weekend, if you get time, because I know this is the end of the semester and you have hundreds of other, stuff to finish off, assignments and projects and stuff. So but if you do get a chance to sit down and absorb this, kind of get it. And on Monday, I'll show you an example that you can try out in MySQL where you can see phantom tuples. So that's why I said, when I first did it and I said, this is not showing up in MySQL, I said, like, should I even bother teaching this? But then I said, you read any book and you go online, you're going to see phantom tuples everywhere. And, then what? So so then I decided, so I had to really play around with MySQL. Then I figured out when MySQL shows phantom tuples. It shows phantom tuples, but the query T2 must have some kind of insert, delete, or update happening. And then you will see the phantom tuples. And I will give you an example, which you can then go and try out. But did you understand this part? Does this kind of, because it's kind of illogical, but this is what happens. And I want you to see what's happening.
Yeah, yeah, I get it. So inserts cause it, but updates don't, basically. Well, you said inserts, deletes, and stuff.
Yeah. All the inserts are going to show. I mean, it's not so much as deletes, it's inserts. It's a phantom tuple. So the inserts will show up. So that's what I'll be showing you on Monday. I'll give you one example because I really had to, it took me a while, because I couldn't figure out how do I show phantom tuples in MySQL, because MySQL is doing repeatable read. It is not doing serializable. So, and finally I understood where it shows. I mean, so I will show you that example. So I don't want you to spend as much time as I had to bring out phantom tuples in MySQL. So, have you understood the three isolation levels? And I have to say that concurrency is definitely the most complicated part, these ACID properties. But you have to understand that databases are all about concurrency. So if you are going to be working as a database programmer, and there is a high probability, whatever you do, databases are so useful that there is a high probability if you work that you are going to work with some kind of databases. So, and ACID properties and concurrency is always going to be there. So even you may, to some degree you'll get it now. And when you start working with it, you'll understand it in more detail. That's all I can say, because concurrency is just not an easy topic. It's a really hard topic. Always. I mean, it's whether you do it in operating, when you run code with concurrency and you have mutexes and locks and all, you have to be so careful. Because when things run in parallel, you get sometimes unpredictable results. So if you have kind of understood this, let me do the last one, which is serializable. And like I said, in the next class, that's all I really need to do. I want to show you the locks, because all of the isolation levels are held in place by locks. So I at least want you to know what these locks are. I'm not asking you to go into details. That's more in like a lower level class, but at least you should know what kind of locks are there in place. But let me talk about the very strongest isolation level, which is serializable. So and today I'll put up this lab come assignment. Concurrency, the only way you're going to get it even partially is if you actually run it out. So open two windows on your laptop and run these queries in parallel. So I tried my best to come up with some kind of, it's like a lab where you kind of run and you just have to play around with it. That's the only way. I mean, I think it's worth investing. I know you're really busy, but the exam is only, it's one of the last exams to be held. So you have time. So just play around with it, maybe 1 hour or 2 hours, and then you'll understand it a lot better if you play around with concurrency on your own. Um, you know, otherwise, otherwise you may not fully get it. It really is a hard topic. But that's the nature of the beast, so to say. It's not, I can't, I mean, you can only simplify things so far, but when the topic itself is complex, I mean, you can't make it totally simple when it is a complex topic. So let's do this last one. T2 runs with serializable. Okay, so it's serializable. That's the thing. Now, serializable is the only level. So all these other cases, when we did, you can have non-serial executions, right? So, but the output most of the time, in most cases, looks like it's serializable. So, but you're running things concurrently. So everything is running concurrently, but output is looking serializable. So that's the whole idea. So let me write in all other isolation levels, transactions can run concurrently. So that's what we have done, you know, so non-serialized. Concurrently means non-serializable. So they can execute, when I say run, they can execute concurrently. And then the output, you know, may look serializable or not. And so this is the thing, okay? But with serializable isolation level, execution order is also serializable. Must. Now this is very, so this is, so the execution itself, so what you're saying is that if you and I, we are running stuff on the same database. So let's say that you are running on the company and I'm running it, and I am saying isolation level serializable. So what I'm saying is your running will also get affected because I'm saying that you cannot run things concurrently with me. We are going to do this in a serializable. So let me show you, and this time I'll show you a simpler example of a query. So let's say T1, which is 2 queries, Q1, which is update employee, and so on. So it's an update query, and Q2 is just a commit, or it could be rollback. It doesn't matter. So that's Q1 and Q2. And then we have transaction T2, which I'm going to run with isolation level serializable. And I have 2 queries, S1, select star from M, and I have S2, which is commit. Or it could be, doesn't matter. So basically I'm saying, so that's just those two. So let me show, so we have the 2 users. Then let's say this is time. And you have user 1 and user 2. User 1, user 2. So let's say that Q1 in absolute time starts up first. So Q1 is coming up on absolute time. So this is user 1 doing Q1. And then later on, I come up. So you haven't committed yet. You have done Q1. I come in and user 2 comes in and does S1. So what's going to happen is that I'm going to hang. I won't be able to execute. It's going to hang. Can't execute anything. I have to wait till user 1 commits, and or the other way around. Time. And you have user 2 doing S1. And then I'm going to have user 1 come in. Doing Q1, and same thing is going to happen. It's going to hang. So that's the thing. So the execution itself is going to be serializable. So if you're going to run that's one of the things we said in the class, that when you do serializable, when the previous class, I think I had that V1 left. I mentioned that when you do serializable, the concurrency is weakest. Consistency and overhead are the highest, because really what you're doing is you're grabbing hold of a lock. And when you do isolation level serializable, even read transaction, normally read transactions do not grab onto exclusive locks. So that's why I want to show you locks in the next class too. I don't have very much to do in the next class. I just have to show you the locking mechanism underneath. And I just want to show you an example that shows phantom reads um, in MySQL. But the thing you have to understand is that when you do serializable, you are taking an exclusive lock, even on read transaction. And when you take an exclusive lock, if another user tries to come in and do something, they're not going to be able to get in because you haven't, somebody else has got an exclusive lock on an item. So be careful using isolation level serializable. So any questions?